The reason why I wanted to do this question with you is because I saw this question on last year's provincial exam. Okay, so this was an actual provincial exam question. So I thought I'd go over this with you so that you can get the right answer when you do your provincial exam. Okay, this is that factoring stuff we did. Okay, and notice the question here, the factoring has this value of a, which is 2. So we're going to have to do that more complicated factoring method, the choose method, decomposition, guess and check, that kind of stuff. The question here says this: what are the possible integral values? Integral means they have to be integers. Okay? So 0, 1, 2, 3, or -1, -2, -3. Okay? You gonna put that away, Patrick? Okay. And it has to be, or they're trying to figure out what factors or what values of k can actually make this expression factored. By the way, if we actually had a number there, how would we actually first of all try to figure this stuff out? We'd find two numbers that multiply to what? Not just -2. -2 times the 2 in front, which would be -4. Good. And those same two numbers would have to add up to what value? K. Good. That's the same. So write that down right now. Okay? Now, what we did next is we had to figure out, okay, what are the different combinations that multiply to -4? And I guess in this case, add to k. But we don't know what k is right now. So let's just do the combinations that multiply to -4. Help me out, somebody. What is one combination of two numbers that multiply to -4? 1 and 4, JC says? Sure. Are you sure?
1 -4.
Oh, 1 -4. Thank you. Good. Somebody else? 2 -2. Any other ones? No more?
-1, 4.
Thanks, JC. -1 and 4. Anything else? -2 and 2? Well, I guess that's the same thing as this one, just in a different order, so let's not write it down. Anything else? Okay, good. That's it. Now, these are the three combinations that are possible, but remember, I don't know what the actual combination should be because I don't know what k is right now. Okay? But they didn't ask you to figure out which one of these worked. This question says, what value can actually k be so that this can be factored? So if I look at each of these combinations now, okay, if I look at the first combination, -1, -4, what's k if I take those two numbers together? K means you're supposed to add those two numbers together, so what's 1 plus -4? -3. Okay, so therefore, I'm saying to you, the k in this case is equal to -3. Okay. What about if I took the next combination? Okay, and write this down, please. Okay, next combination. 2 and -2. What's my value of k in this case? How do I find k again? I add the two numbers together. What's 2 plus -2? 2 plus -2 is 0. Thank you. So k could also be 0. And then looking at the last one here, -1 and 4, if I were to now add them together, what's my possible value of k in this case? 3. So ladies and gentlemen, this is what you've actually just solved for me. You have already just told me the possible integral values of k. It's -3, 0, and 3. So I'll just say the possible values are, and I'll write this down, the possible values are -3, 0, and 3. So these are the three answers for k, so that when I plug it into this expression, I can actually factor it into the two brackets. Okay? So I thought I want to show that to you because I forgot about that. Okay, we'll do some more practice like this maybe next week as well to help you get ready for your test. But what I'd like you to do now is if you can still grab a special piece of paper, and I'd like to quickly go over these questions from your worksheet last day. Okay, and I'm going to do them first with you before I give you back the worksheet, because I want you guys to look at this together. Okay? All right. Okay, let's do this one together. Okay? Listen up, please, and if you don't write this down, that's fine, but I would strongly suggest that you do somewhere. This was question number 16 on the worksheet that I just gave you, and I'll give that back to you in 2 seconds. A lot of people got this one wrong. A lot. A lot. Too many. So I want to do this one with you together. Okay? Let's do this, number 16. Okay? I look at this, and the first thing that scares me is the negative signs. Thank you. I don't like having a negative sign in front of the squared term. That's just me. So what I prefer to do is I'm going to factor out the negative. Is there anything else I can factor out, by the way? No, so just the negative. So let's do this together. Let's factor out the negative. So we get 6a squared plus 25a minus 25. Okay? Do that first, please. Okay. Thank you. Why should it be minus 25? It's wrong. What should it be? Right. Negative 25 divided by negative 1 is positive 25. Good. Okay. Good. Now, for those of you who feel comfortable factoring, start to factor this now. So remember, you're trying to find two numbers that multiply 2, and I'm going to do 6 times 25. I know that number is pretty big, but think about quarters. If I have 6 quarters, how many would it be? Yes, Katrina? How much? 125? That's 5 quarters. 150, yeah. 150, okay? And those same two numbers have to add to 25. Okay, think about that. What times what gives you 50? What's the combination? Anyone have a combination here for me? What is it, Millie?
Oh, wait, no, not that one.
Very different? What times what gives you 50? 150 is 10 and 15. Good. 10 and 15. Good. So I will put in 10 and 15. And let's take a look together, please. So 10, 15, that becomes 150. 10 plus 15 is 25. That's great. Remember now I'm going to factor this by I'll use choose method. So that's x plus 10, x plus 15. Okay, and now here's where some of you made mistakes when you did choose method. Listen up, like JC. What do we need to do next? Divide by 6. Good. Many of you did that, but this is the step you forgot to do. Some of you just said, oh, divide by 6. Let's do bottoms up. 6x plus 10, 6x plus 15. Wrong. What do you have to do next after doing that? Simplify. Thank you. Some of you forgot to do that on your worksheet. What's 10 over 6 simplified to as fractions? 5 over 3. Thank you. Okay. And then how about the other one? 15 over 6. Divide that by what? 3 each. So what's 15? That's 5 over 2. Now you can do the bottoms up. And so your final answer here should be 3x plus 5. And then here's 2x plus 5. And if you left this, oh, sorry, it's A, my fault. A, oops. And if you left it like this, I'm still going to be sad because, yes, like what Brian says, don't forget you have this negative in front. You have to keep that negative there, and a lot of you forgot to do that as well. So this is your final answer for 16. Okay? Oops. Okay? Now, I also want to do 17, but I'm going to skip that. Let's go to do 18. So let's take a look at 18 now. I'm going to ask you to see if you can start this off while I go see Mr. Chow. Let me just go ahead and stop my recording first. Ah! Where is it? Oh, there it is. So once again, factor out the GCF first. Okay. Find the right combination right now. What's the right combination?
25.
Okay. Find the right combination, please, dear friends. Finish this one off. Can someone tell me the combination that works for this one? What times what gives you negative 10 and they add to 15? Help. Negative 5 and 20. Thanks, Ramonica. I think that's correct. That looks good. So then I'm going to now factor this. So instead of having x, I'll put b minus 5, b plus 20. What's next? Simplify. Simplify what?
No, I mean like bottoms up.
Bottoms up? That's after simplifying. Divide by a, yeah. What's my a value here? Okay, don't say 16. Say 4, because I'm looking at what's now inside the bracket. So it's 4. Now we'll simplify. And I think the 20 divided by 4 is a 5. And then now we'll do Suleiman's bottoms up. We'll bring the 4 up here. So 4b minus 5, b plus 5. Am I done? Am I done? Am I done?
Yes. No.
Oh, what did I forget? Yeah, Katrina, what did I forget? Oh yeah, put the 4 in front. Don't forget the 4. Okay? All right. I hope that was a good review. Yes, Suleiman.
About the quiz.
That's not a quiz, but the worksheet.
Okay. Number 14.
Thing called factoring special polynomials. There's actually 3 different special ones. And one of them actually comes from this square. So what I'd like us to do is with this square piece of paper, can you please label each length as A? Let's call this side length A and this called A as well. Okay, so please do that. Actually on your sticky, write down letter A and A. Okay? And I'm actually going to draw this out here too. Okay, so I want you to draw as well. So draw. Okay? Draw and do the same thing. We're doing both. We're doing this and the drawing. Okay? Okay. Now, ladies and gentlemen, shh, listen up. What's the area of this square then if I call each side length A?
A squared.
A squared. Good. So A squared is the area. Now here's what I'm going to do. Okay? Watch me first, and I'll let you try this on your own as well. Okay? From one of the corners, I'm going to, I guess, measure. I'm going to measure, I don't know, about a thumb's length. I'm going to rip it. I'm going to do this. Okay? I'm going to try and create a smaller square, and I'm going to rip that from the larger square. Okay? So watch me first. Watch me first. I know some of you are doing this. Hello. Watch me first. So I would like you to actually take out a small square, and let's call this a different length. Instead of A, what other letter can we use? How about B? Okay. So I'm going to ask you to remove the B squared. So when I remove B squared, what's the operation for remove? Plus, minus, which one is it? Minus. So what I want us to show in a picture form is this: A squared minus B squared. Okay? Do that right now. So just whatever you choose, make a measurement, just try to get rid of a square. Okay? That right now, please. Do that. Okay, take it, rip it, stick it next door. Okay?
What?
Okay?
Oh no.
It's too big. It's okay. Keep doing it. So once again, take the piece on the top, rip it, and then stick it on the side over here to make a rectangle. Okay? Our goal is to make a rectangle. Okay? And I'd like you to draw this out too in your notes. Okay? Draw it out. Patrick, that's not right.
What's this? So it's this way. What's this? Okay. Sound that.
Okay, ladies and gentlemen. All right, can we come back here, please, at the front? Have you drawn this in your notes yet? If you haven't, do that right now, please. Okay. what I'd like you to do now, for those of you already ahead, is I want you to think about the following, okay? Can you describe to me what this length is equal to in algebra terms? And can you describe what this length is equal to in algebra terms? Okay? Don't tell me the answer, just try it on your own. Okay. Okay. Patrick, seriously, focus please. Okay? Mehdi, you okay, man? Look spaced out. Okay, so let's take a look once again. I'm asking you, what is the expression for this length? What is the expression here for the height? Okay, somebody help me out here. Shh, listen up. Length, please. A plus B. Can you see how this length here is equal to B? Right? So that whole length here is just A plus B. Write that in. Okay. Now, what about this height here? What's this side equal to? A minus B. Good. Write that in, please. Now, if I asked you to find the area of this object now, this large rectangle, the entire rectangle, what would the area be equal to in this case? How do you find area of a rectangle? Length times width. A plus B times the width. A minus B. Now, ladies and gentlemen, we started out with this. And then I took this part and I stuck it over here. Can you see how this shape, these two shapes, is really the same as this shape up here without the b squared removed? Same? Yes or no? Right? The areas are the same? Did I add anything to this? No, same, right? So if the areas are the same, and this was the expression for the area up top, and this is the expression for the area over here, and those things are the same, what do you know? Here's what you know. A squared minus b squared, what you had on top, is the same thing as a plus b times a minus b. Please box this, star this, do whatever you need to do to make sure this is important. Because, ladies and gentlemen, this is one of the first special factoring expressions that I want to show you today. Okay? Now, there's a special name for this. This is called a difference, okay, of squares. Can you see why we call it a difference of squares? Why do you think we call it a squares, first of all? Square, square, right? Square, square. Why will we use the word difference? It's the minus sign here. So difference of squares becomes a plus b, a minus b. Okay? Now, before we actually start doing some of these questions now, I want you to make a note. This binomial a squared minus b squared can also be written as a trinomial. I know some of you like trinomials, 3 terms. If you want to write it as a 3-term thing, it'd be a squared. You have a b squared at the bottom or at the end. And then in the middle, I suggest you write down this. If there's nothing there, what number do we use for nothing?
1.
Not 1. Not x. What number? 0. So sometimes we'll do something like this, 0, and we'll do an AB here because there's A and B involved, okay? I personally don't like writing like this, but if you want to, because you think I like to see trinomials, so be it, okay? All right, now before we actually do some of these factoring questions, let's see if we can actually figure out some perfect squares. As a quick review. Shanaz, you with me? Okay, help me out. What's the perfect square for number 3? What would that be? Shanaz, that's it this time. What's the answer here? 9, thank you, good. Okay, next one, Patrick B, help me out. 4, what's the perfect square for 4? So 4, 12, no, careful. Oh, 16, thanks, all right. Ray, help me out with the next one, number 5. Perfect square for this. Ray. 25, bravo. Okay. Jack, you want me to the next one? 6. 6 squared is 36. Thank you. 7. Joanna, you want to help me out with this one? 49. Nice. 8. Lawrence, help me with 8.
64.
Cool. Okay. Yelena, you want to do number 9 for me? 9 squared is? 81. Thank you. Ramonica, how about 10? 100. Sweet. Stella, give me 11. 121. And all of us together, give me 12. 144. Okay. I'm going to ask you to memorize these. If you haven't memorized them already, you'll see them a lot. You'll use them a lot. You should know them by heart. Okay? All right. Let's take a look at these together now. Okay? Let's actually do some factoring. Notice I'm going to say now factor each binomial. Why do I use the word binomial instead of trinomial? Bi means 2 terms, right? X squared and a 4. 2 terms. I'd like you to factor this for me. Okay? And I'm going to show this to you 2 ways, using this idea of a difference of squares. And I'm also going to show you the algebra tiles so that you can see a visual picture of what's going on. Okay? What should I do first? Let's do difference of squares. Can you see how this is a difference of squares? Something squared minus something else all squared? So can you look at this and look at that up there as well? What would be my value of A and what would be my value of B if you were just to compare the x squared minus 4 with the a squared minus b squared? What would this be? X squared compares with the a squared. So what's a equal to? What's a in this question? It's just x. Good. How about the next part here? The 4 and the b squared. So what number is b if b squared is 4? 2. Good. If you can do this, you're well on your way. Okay. Now, hey, ladies, with me, please, okay? You need to know this, Jeanette. Now, help me out here. If I were to now identify a and b, well, what we said up top is that a squared minus b squared is the same thing as a plus b, a minus b. So the factored form is just this. It's a plus b, so what's my a value? It's the x. What's the b? So it's x plus 2. And the answer over here would be x minus 2. That's it. We're done. Good. Where did the 2 come from? Ladies and gentlemen, once again, you see how this is a 4? This is supposed to be equal to b squared. So some number squared gave me 4. What was that number that gave me 4? 2. That's where it comes from. Now, ladies and gentlemen, let me try to show this to you visually too. Okay? So I'd like you to actually draw this in your notes as well. We're going to do some algebra tiles. Okay? So draw the little bar. Let's do this by algebra tiles. I want you to see this to understand this. Okay. What do we have here again? The question was x squared. And what else was it? Minus 4. Okay, so I'm going to take out the 4 negatives here. 1, 2, 3, 4. Okay. What's my job when I factor here again? I want to put these things in a spot where I can make a nice rectangle. Good. I've got an x squared by itself. What should I do with these 4 little pieces? Like that. Uh-oh. Okay, so like this. Uh-oh. Where do these usually go, by the way? They usually go in the corner over here, right? So maybe I should do it like this. But wait a minute, I'm missing stuff up here and over there. Uh-oh. Maybe I should do stuff like this. But I'm still missing stuff. Uh-oh. I give up. 0 pairs. Suleiman, what do you mean by 0 pairs? What should I put in as a 0 pair? A 1 of the x? Okay, hold on. Remember, that's not a 0 pair. Here's a 0 pair. Right? I need 2 of those, Rod says. Okay, now what do I do with them then if I have 2 pairs of 0 pairs? Where do I put these now in my picture? Where do I put them?
Don't you
Switch them. Rotate them, you mean, JC?
and take 1 pair out?
Which one? The green ones or the white ones?
1 green, 1 white.
1 green, right there?
And then put the white one.
Down here? Yeah?
No.
Yeah, because they have to line up, right? They have to be like the same colors, right?
Put it where is it?
And then this one will go? Yep. And then?
Oh,
Okay, now. Take a look at what we have here as our length. Let's look at the length. This would be What would that be? An x, good. And what would this be? This is plus 2. X plus 2, good. Now what about the actual width? Oops. Let's do that. That would be x. And then what about those two white things down there? Minus 2. Okay. Draw this in your notes. Okay. So we're still doing 1A. So here's what I'd like you to do. Draw this in, please, right now. Here's your x squared. Draw that in. Okay? Here are your 4 negatives. So there's your minus 4. Okay? Now, to complete this picture, what did we need to do, Suleiman? 0 pairs. So notice in this case, you need to add in what we call the 0 pairs. And which pairs did we add in? Well, we added in a positive x with also a negative x. Was 1 pair enough? We need 2 pairs, right? So yeah. So I'm going to show you by drawing this in now, the 2 pairs. And then let's actually add them in. And show me how you would add them into your picture. Well, you would have the 2 positives on one side, I think. So positive x, and then your 2 negatives somewhere else. Okay. Ray, JC, let's focus here, please, okay? And then don't forget, your final goal is to figure out what the length is. And up here I have x, and then I have plus 2. So that's my first factor. And then down here, I have my next one. Okay? Now, okay? Some of you did this, okay? The idea is what squared gives you 9x squared. So think about this. What squared gives you 9? 3. Good. So A must have a 3. Now, what squared gives you x squared? That'll be just x, because x times x gives you x squared. And if you want to figure out the b value, you're looking at the 16. So what times what gives you 16? That are the same numbers. 4. Okay, now don't worry about the negative, okay? Because we know this is a difference of squares. I'm just focusing on the actual number. If you found out a and you found out b, the rest is pretty easy. Just use the formula. A plus b, 3x plus 4, and then 3x minus 4. Done. Okay, if you drew out the pictures, you would have found this same thing. 3x plus 4, 3x minus 4. Okay? Now, what I'd like to do is the same question again, but this time just watch me, please. Okay, don't write this down, just watch. Okay? Another way. Other way. Just watch. Okay, just watch. I want to write this as a trinomial. Okay, just watch. You don't need to do this, just watch. What number goes inside here? If there's nothing. I showed you that was a 0. So if you want to think about how we did this and connect this to what we did last day, then this is what you should be thinking. Find 2 numbers that multiply to, what, 9 times 16 is? Help. Someone on the calculator, can you do this for me? What's 9 times 16? Negative 144. Good. And those same 2 numbers add to 0. Okay, here's a key thing. You see how it adds to 0? What do we know about these 2 numbers then? If they add to 0, they should be the same except the signs are different. So what 2 numbers are the same that multiply to 144? 12 and 12, okay? So 12 and 12, and I just told you one of them had to be negative, so I'll make the second one negative. Okay? Now, if I were to do it with last day's method, that's x plus 12 times x minus 12. Am I done? What should I do next? Before bottoms up. Before simplifying. Divide by 9. Okay, now we'll simplify. What's 12 over 9 simplified? 4 over 3. Good. 4 over 3. Good. What do we do next? Bottoms up. 3x plus 4. Very good. 3x minus 4. It's the same thing. Same. Okay, so your choice. You choose either to do a difference of squares, or every time you see a difference of squares, do it this way by putting in a 0. Whatever works for you is good. Okay? Wow. Let's do 2 more examples, and I think I have to stop for today because I don't have much time left. Wow. Okay. Try 1C and 1D, please. Factor out the GCF. Shh. I got 5 minutes left. Patrick, you want to put away your phone? Thanks, man. Okay, so part C here. Let's take a look. If you're going to do it the quick and easy way, my suggestion is to, once again, identify A and B. So what's A if this whole thing here is A squared? 4, what else? Y. Good, right? Because 4 times 4 is 16. Y times Y is Y squared. Yelena, you with me? Next one here. 25x squared. What do we have here?
5x.
5x. Veronica? Yeah. Huh? So we get 5x. Good. So what's the brackets going to be then? Well, it's just A plus B, so 4y plus 5x. And then 4y minus 5x. That's it. We're done. Okay? If you did it the other way, where you put a 0x in there, that's perfectly fine as well, but you should have got the same answer. Okay? So I'm not going to show you because I'm running out of time. Okay? Let's do D. D is tricky because you're like, Mr. Lee, nothing squared gives you 3. I know that. So what do you think I should do first for this one?
Multiply.
Not multiply, but I always say to you, factor out what first? The GCF. So let's factor out a 3 first. Okay. Now what's 48 divided by 3? 16. Excellent. Okay. Now let's continue to factor this because now I see in here this is also a difference of squares. I'm going to ask you to tell me what A is. I'm going to ask you to tell me what B is. Let's do the easy part first. What's B? 4. Good. Now the tricky part is A. What squared gives you x to the power of 4? X squared. Awesome. Because x squared times x squared, you add the exponents together, x to the power of 4. Well done, Mehdi. So now let's go ahead and factor this again. So this would be then A, which is x squared, plus B, and then it'd be A, which is x squared, minus B. Don't forget the 3 in front. And are we done? You wish. There's more. Because look, I see another difference of squares right here. Okay, so let's do it again. Yeah, what's the A value in this case? It's x. What's the B value for this one? It's 2. So this part, you think that's funny? Okay, let's focus here, please, okay? X plus 2, x minus 2. And then what about the stuff in the front? That's right, put the 3 in the front. Also put the x squared plus 4 in the front as well. So finally, after all that work, this is what I call the fully factored form. Okay? I kept the x squared because I can't factor that part. I can only factor what I call difference of squares. This x squared is from there. Excuse me, don't pack up your stuff yet. Okay? Yes? You can only factor one with the minus, yes. That's why it's called difference of squares, not the sum of squares. Okay? Don't go yet. I gotta give you some homework. Here's your home learning. Write this down. Page 194. Question number 5, 6, 10, 13. That's it. Try those. Next day we'll come back, we'll do more.